Okay, in the previous video, we have discussed signal conditioning, and as a part of signal conditioning, we have discussed about operational amplifiers and the application of operational amplifiers, such as adding two signals, differentiating a given signal, or integrating a given signal, or finding the difference between two signals. So those things we have discussed, right? So in this video, what we're going to do is we are going to use simulink and do the analysis, or just put the circuit in simulink and check, okay, what's the input and what's the output. So that's what we're going to do. Okay, so for that, the problem which we are going to take is, so this is the, okay, for our analysis, we are going to take integrating amplifier. Okay, so this is the integrating amplifier. So in the chosen problem, we are going to choose the input voltage as a sinusoidal voltage. Okay, input voltage is a sinusoidal, which means AC voltage with the peak or amplitude of 4 volt. Okay, and we're going to choose the resistor as 10 ohm and capacitor as 10 microfarad. Okay, so for such a thing, what's V out? And this is what we are going to identify. Okay, so how to design this in Simulink? Let's see. So first we will open Simulink, and then this is the space where I put all the blocks and everything and make the circuit. And this is my library browser. Okay, so first let me find op-amp, which is known as operational amplifier. So let me drag it over here. Okay, what else I need? I need resistor, right? So where is the resistor? Okay, here it is. Okay, and then I need a capacitor as well. Okay, I have a capacitor. And then what else I need? Voltage source, right? I need an AC voltage source. Okay, so let me drag that one as well. What else I need? Okay, reference voltage, so which basically means ground. So this is the electrical reference. Okay, and then see, okay, I connect all the circuits, but I need to measure the voltage, right? I need to measure the V out, right? So for that, I need voltage sensor. Okay, so where is voltage sensor? Yes, we have here. So that's the voltage sensor. Okay, fine. And I also require one more thing, which is simulink converter. Okay, so this is simulink converter. So I'll tell you what is simulink converter. And also we require something called solver. Yeah, solver configuration. Okay, so these are the things we require, and if we need more, we can, I mean, more of the same thing, then we can copy it. Okay, so I'll put this. Okay, one more thing we require, which is scope. Okay, I forgot that. Right. Okay. Now let's connect all those things. Okay. Let me put these things aside. Okay. Now we have the voltage source. Okay. And one more thing. Let me show you the amplifier. If you see here it's minus and here it's plus. Okay. But in our so here in the simulink, this is plus and this is minus. Okay. So for the sake of consistency, what I want is I want to switch this operational amplifier. Okay. So such that this is minus and this is plus. And how to do that? So let's select it uh, and go to format and then flip block and say put up down. Okay. And if you do that, you have got it switched. Okay, now we have the operational amplifier. Now we are going to connect the resistor to this one. Okay, and then this is to the resistor. Okay, and then this one I'm going to connect it to the ground. And okay, let me put this one aside right now. Okay, and then this capacitor. Okay, so the capacitor I'm going to connect it over here. Okay, and then this once again I'm going to connect it. Okay, and what about here? That I'm going to connect once again to the ground. Okay, I didn't connect it properly. Okay, right, right. Okay, so that's the completion of the circuit, but I haven't given the values, right? So voltage, so I'm going to choose the voltage. The peak is 4, okay, hertz. Okay, the problem I didn't mention the frequency, but I'm going to choose 1000 hertz. Okay, and then what about the resistor? The resistance value is 10 ohm. Okay, that's the value we have begun with. And then the capacitance, which is 10 microfarad. So which is this one. Okay. Okay, I think we have given all the values. Okay, the circuit is ready, but we need to sense the voltage, right? So this is the input voltage, and here we will get the output voltage, right? So for that we need voltage sensors. So since we need to sense both input voltage as well as the output voltage, we need two voltage sensors. So I'm going to copy this one, Control C, Control V. Okay, I have two voltage sensors. Okay, okay. Now, so how am I going to use this voltage sensor to measure V in? I'm going to connect one to this side, okay, and another one to this side. Okay, so that's how I connected one voltage sensor here. Okay, and similarly for another voltage sensor, I'm going to connect one over here and another one over here. Okay, fine. Now, so whatever I measure is voltage, okay, but I cannot directly read it, okay, because it's like a circuit current, okay, but in order to convert that into a number, I need this PS simulink converter. Okay, so what I'm going to do is, okay, I also need this one. Oops. Okay, so one I will connect it to this one. Okay, and this one I will connect it to this one, and I will give these two things to the scope. Okay, these two things to the scope. Okay, maybe yes. Okay, and then okay, everything is fine, but we also do need to do one more thing, which is we need to connect the solver configuration. Okay, so otherwise it will not work. So what we need to do is we need to connect this solver configuration to anywhere in the circuit. So I'm just going to connect it over here. Okay, fine. Now I have done everything. Now let me run, and if I run, okay, now let's check in the scope. Okay, and one more thing you notice, here the start time I have chosen is 0.008. Okay, so the default value is 10. Okay, if the default value is 10, okay, and we are giving the signal 1000 frequency, okay, so which means within 1 second you will see the 1000 peaks. Okay, so which means you cannot see this sinusoidal curve. You just see a band. Okay, so you need to choose according to your requirement. You need to choose the stop time according to your requirement. Okay, okay. So finally, we have got this as the answer. Okay, so let's see. So this is the input voltage. Okay, so if you see, the peak is 4. Okay, and right, the peak is 4, and this is 0.008, which means this is like 1 millisecond. Okay, so since it's a 1000 hertz, within 1 millisecond you could see one cycle, right? Okay, now what this is the output. Okay, so the input is sine wave, okay, where the output is cosine. Okay, the output is cosine. Okay, because if you integrate sine, you will get cosine, right? So that's what you have got. Of course, you will get some minus and all those things, but that's fine. Um, right. So this is the integrated signal you have got, but at the same time, it will get amplified. Okay. The amplification factor depends on what is the capacitor and what is the resistor which you have chosen. Okay. So in a similar fashion, you could design the other amplifying circuits. Okay, so for a given requirement, okay, so what you need to do is you need to choose the value of the capacitor, the value of the resistor, and the type of circuit, everything. Okay, such that if I ask you to for a given input, if I ask that I want to achieve this particular output, then you should be able to design. Okay, so what I suggest is, so here we have discussed only one amplifier, which is integrating amplifier. You do practice with different other amplifiers. Okay, by choosing some appropriate the resistor capacitor values. Okay, and yeah, practice. And in the next video, we will see another signal conditioning process, okay, which is filtering, okay. So we will discuss that in the next video. Thank you.